Ah, yes, the beach. Everybody loves the beach. And what's not to love? Sunshine, fresh air, the sand beneath your feet, and the gentle rushing of the waves onto the shore. If you've been to the beach, you may have noticed that at times the water level is way down low, and at other times the water level comes up high onto the beach. We call this rise and fall of the water level tides. In some places, this rise and fall is quite gentle. In other locations, this rise and fall can be quite drastic. Here in the Bay of Fundy, on the east coast of Canada, this rise and fall may be as much as 45 feet. In this video, we'll explore what causes the tides.
Hi, this video is on tides. Now, you've experienced tides if you've ever gone to Galveston or anywhere else along a coastline. I personally enjoy tides because it allows me to bodyboard every time I go down to the ocean. Also, it helps us collect seashells along the beach. The objectives for this video we're going to discuss is what causes the tides, how many high and low tides are there during a 24-hour period, what are spring tides and when do they occur, and what are neap tides and when do they occur. Now I want to point out two new vocabulary words. Spring tides, you're going to need to know the definition of by the end of this video, and neap tides by the end of this video. Now to think of, we're going to start out thinking about a ball of water out in the solar system. Circular, no other forces acting on it. But we know we have a moon, and the moon acts upon this body of water, and it pulls the water in that direction of the moon. And that causes the body of water to elongate. It's no longer circle. It's more of an ellipse than just the ball of water we started with. Now I've gone ahead and added land now to represent where we live. I've also drawn here the little white dot that's going to represent the North Pole, because this is going to be a top-down view of all the views I show that we were in space and we're looking down from the North Pole, and we see the moon and the sun in that. Also, this video will not be to scale or distance. It's just a model, and we've talked about limitations and models in previous lessons. Now, you notice when we add the land here, we get a wider spot here and here, a spot towards the moon and on the opposite end from the moon. And we also get not as wide here and here. Now these bulges are going to represent, here is when we experience high tide, and at these locations we experience low tide. And from previous videos, and that we experience day and night, then we know the Earth rotates. Okay? We're going to say it rotates in this direction. And we know that the Earth rotates faster than the moon revolves around the Earth. So we're going to say if we were standing right here, we went to the beach, and we're staying in a nice condo on the beach, we would be experiencing high tide. And as the day passed, we would rotate in this direction again. We'd eventually get to this spot where we'd experience low tide. We would then rotate back to this spot, experiencing a high tide, again low tide, and back to the high tide where we started from. So during the 24-hour period, we will experience 2 high tide and 2 low tides. Again, bulge always facing the moon and on the opposite end of the Earth. Now, the first position I want to show and talk about is spring tide. Now, spring tides are higher than normal high tides and lower than normal low tides. And that has to do when we add the sun as a player besides the moon. Now, the moon always has the most effect because it's closer, sun being much further away than our moon. So in this picture, we've drawn the new moon phase, and we can draw the gravity pulling in this direction from the moon, and the sun pulling, sun's gravity pulling in that direction. And they're both pulling in the same direction, so they have that added force. Okay? And here I've drawn our original high and low tides in the dark blue, still the same, and still the same top view where we're looking at the North Pole down. Now I've added this light blue here to show the difference in that this is a spring tide. Again, showing that it's a higher high tide, because if we measure this distance here, it's much wider. It's lower here, not as wide, causing a lower than normal low tide. And this is a spring tide. Again, we have the new moon phase. So when else do you think this happens? Here it actually happens also in the full moon phase. But what you see here, though, is moon's gravity is pulling this way, sun's pulling this way. And that might not be as intuitive looking. You're looking at, well, they're pulling at different ends. But think about tying your shoe when you pull on a knot. When you pull on the knot, you pull both sides going in opposite direction. And the knot shrinks, right? This knot gets tighter. Well, this is what's happening here. It's still on the same plane, even though they're in opposite directions. So they're kind of pulling the knot tighter. And so they're elongating the water more, even though they're both in opposite directions. So again, we get a spring tide. Okay. And again, this happens in the full moon phase, which I've shown here, and back to the new moon phase. We both, during those phases of the moon, we experience spring tide. Again, a spring tide is a higher than normal high tide and a lower than normal low tide. Here, now I've drawn third quarter position of the moon. Still have the sun. And here we have sun's gravity pulling this direction, and we have the moon's gravity pulling in that direction. Now they're not quite in the same plane. Now they are perpendicular or 90 degrees. This is where we get a neap tide. Okay. Now, the moon, again being closer to us, moon will always have the high tide in that direction. Here I've drawn it in this light blue again, here and here. So these would be the high tide locations again. Now, during the neap tide, you can see we don't get as big as a bulge because the high tide still being higher, but it won't be. It's a little bit less than normal. And then the low tide doesn't change much either. It's still a low tide, but it's not as drastic change of a low tide. So here we have the high and low tide not having a drastic difference, but there is still a difference because, again, the moon having more gravitational force than the sun. And this is a neap tide. So in conclusion, through this video, we know that gravity of the moon and sun cause the tides. Most of the time you might have just heard the moon, but both we've seen do play a part in the tides. There are 2 high tides and 2 low tides every 24 hours. Spring tides are higher than normal high tides and lower than normal low tides. Spring tides occur during new and full moons. Neap tides are high tides, not as high, and low tides not as low. Neap tides occur during first and third quarter moons. Thank you. I hope you enjoyed the video and learned about tides. Again, you're welcome to replay it or prepared for the next activity. And again,